So with what we talked about in that last video in mind, let's try and think about the real numbers, and we'll get to this in a second, in that Gaussian way, where we're just talking about them in terms of giving, taking, but all those interactions, they occur along a single axis, a single line, the number line. So if we want to describe the real numbers, what we would have is, well, a line of them. We'd have that single, the word I'd use there, dimension of things that can happen with the real values. And for a very long time, the thought was that's good enough. That describes all of the reality we need. That's why we call them. That's why Descartes called them real, because they're reality. But if we then think about the imaginary numbers instead as lateral, as something that goes off in its own direction, think about them jutting off up and down from here, then we have a little bit more of a picture of not only their ability to do things, their ability to be relevant to the mathematical discussion, we also kind of get a sense for the fact that there's a bit more going on between the real numbers and the imaginary numbers, that there's a connection we can talk about there in terms of this plane of information, where this is what's called the complex plane. We're looking at the complex numbers a plus bi, where a is what's called the real part, and b is what's called the imaginary part, as it's what gets attached to the imaginary unit I, where if we have numbers of form a plus 0i, those are just numbers a. Those are just the values along that real axis. And similarly, if we talk about numbers of form 0 plus bi, well, we're not along that real axis anymore. We're just being imaginary. And that tells us, and we're looking at the complex numbers, that encapsulates all the possibilities for imaginary things and all the possibilities for the real things. So the complex ones are really the root of the whole system. They're describing every single value that can go on in here, and that leaves a whole lot of room open for a lot of work, and in particular work with this complex plane. But while this is interesting, it's more of a pre-calculus topic. So we're not going to spend too much time on that plane there, but I think seeing that visualization combined with a bit more of that history of where these complex values come from and where their name comes from in terms of being complex and imaginary, I think it helps understand why they might be worth discussing beyond being a matter of Descartesian mathematical, that's actually pretty good, convenience. And with that bit more context in mind, where, as I said, I told you some of the answers would be better than others, now we can start talking a little bit more about how they work, beginning with how we can perform operations on, with, and in terms of complex values.